Welcome. Now in this lecture, we're going to talk about flowcharts, why we use them and what the different symbols mean. Now in programming, there are two significant issues as programmers that we run into when it comes to the program not working the way we'd expected it to work. The first one kind of touched on in a previous video, and that is syntax errors specifically. We'll look at that as we start coding, and in those instances, think of it as a typo or a spelling error. The command that we wanted to have performed, or the tasks that we wanted to do, didn't get the correct directions or instructions to be able to do it. Now the other one, and those are fairly easy to find because the program tells us approximately where the issue exists when we try to run it. Now the other type of issue that comes up is what we call a logic error. Now a logic error, we deal with them all the time in our everyday lives, and it kind of boils down to, well, that didn't turn out the way I expected. And I may have thought things through, but there was one tiny facet of it that I didn't plan for. Now, flowcharting allows us to take that algorithm that we've created and ensure that the logical progression or the logical flow is functional. Now there are a couple of different, more than a couple, there are a few different types of software or software applications that we could use. And I've got on my screen Raptor, which is one of them. And I've used Raptor for a very, very long time. It is a good application. It has its limitations, but for this example, it'll work just fine for us. One of the issues with Raptor is it does not function with Apple products. There are alternatives such as Flowgorithm that does, and they all work about the same. Okay, so let's start out with the interface and the symbols. In our algorithm, we had a start and an end, and the program is what takes place in between. To the left, we have a few different symbols. Now, each one of these symbols represents a different task or action. Now, assignment is something that we talked about in a previous video. We assign some value to some memory location. I asked the user for their age. It was a number. I take that value and I store it somewhere. I assign that value to that variable, or I save that information in, or save that data in that space in memory. So an assignment variable, or an assignment symbol, that's not something that necessarily is an input. So let's look at the inputs and outputs. Say I ask the user, so that's going to be an input. I've got an input coming from the user. And I'll go ahead and save this as test. So I've got my input. We see the arrow coming in. If it was an output, it would be an arrow going out. I'm going to drag an output because at some point we're going to have an output. So I want to get an input. I'm going to need an assignment for what we're about to do. And I'm going to want another assignment right in there. So when the algorithm that we discussed earlier, we ask the user for some value. Before that, we've got an assignment. So let's set divisor equal to 2. What are we going to divide the age by? So I have some variable called divisor has a value of 2 stored in that memory location. Let's go to the input. Okay, please enter your age as a number. Okay, and where do we want to save that variable? We'll just give it a name of age. Okay, please enter your age as a number. See if so please enter your age as a number, and I put that in quotes because that is a string literal constant, a constant string of characters that doesn't change. And for this, it may not print out the way that I want it to the user, but this is something that we'd get used to and how we present text to the screen. We'll pass it to the print statement as a string literal constant. So we're getting the age. We set divisor equivalent to the value of 2. So what's the next thing we're going to do? We're going to perform a mathematical calculation. Let's go here, and we're going to say half age, and I wrote that in camel case, and that's going to be age divided by divisor will be half age. And that is a valid variable name. They'll give us examples in this application. So half age is getting assigned the value of the result of this mathematical equation. Here, we're going to say half of your age is half age. Now, doing something here that's called concatenation. I'm taking a string literal constant. This doesn't change every time we run this, it'll be the exact same. And I'm combining it, I'm not adding it, I'm combining it together with whatever's in half age. And this application is going to take that and convert that into a character and display it for me. It's implicitly being done because what's in half age is a number. Okay, so there's some things that are taking place implicitly. We bring that character 2 in, or I take that number 2, I store it in divisor. I bring a character in from the user, convert it to a number, and store it in age. So this is the logic of what's taken place. Step by step, each thing that we had in our algorithm. Now, if we want to go test this to see, does it actually work the way we logically thought it would? Okay, please enter your age as a number. 24. And then the system outputs half of your age is 12. Right, there were 6 symbols evaluated. 1, 2, 3, 4, 5, 6. 2 of them are given. Okay. Let me clear that. Come back. Why do we do this? Well, what if this one was changed around and I declared age before I got age? Now let's go ahead and run it now and see, will it work for us? The variable age is not found. So this helped us to identify an error in the logic or the flow of our code. Okay? So it won't work if we put things in that order, but it will work if I put things in this order. Boom. So it's doing the calculation the way we want it to do. There are other symbols here. Call will reach out and get another function. And we'll talk about different functions in the coming modules. And functions are our way to essentially outsource some code or functionality. I don't need to know how to do everything. As long as I know somebody that can do it, I can pay them to do it for me, or they'll do it for free if they're gracious enough. And in this context, if I have code that's already been written that performs a task, I don't have to rewrite that code. I just invoke it or call it, just like calling up a contractor to perform work for me. And that work gets performed. And I don't have to worry about it. So that's what this call symbol is. We have a selection symbol, which is we select one path or the other. Do we do option 1 or option 2? That's a logic structure that we'll deal with later, as well as the looping structure is what we'll call a repetition structure. We will perform some task either a specific finite number of times, or it could go on until some action causes it to end. Okay, so that's what flowcharting is, what it does. I'm not requiring you to do it in this course, but I suggest that you take time and play with either Raptor or Flowgorithm. I'll have a link in the resources page for you that you can go download that or access those tools, but become familiar with this way to help you build your tools, if you will, in your toolbox to be a better programmer. Over time, this becomes something that's built into how you code, and you don't have to actually use a tool to do it. But there are times that you may have to do one of these for some other course that you're working in a team. Just because you understand the logical flow of it doesn't mean everybody else on the team understands it. If you break it down into a flow chart, everybody can see the logic and see the functionality that you've created. Okay? So I'll see you in the next video.